Today we are going to discuss about a chapter which is most important in all branches of the engineering and sciences, that is properties of matter. In our syllabus, in properties of matter, we have four properties: elasticity, surface tension, capillarity, and viscosity. So, what is the need of understanding the property of a matter? Before entering into the chapter, you have to get the clear cut idea about why you have to study the properties of a matter. What are the advantages? What are the disadvantages if you are not studied well the properties of matter? Without understanding the properties of matter, what happens? It leads to the adverse effects. So you have to understand the properties of matter before doing anything, right? So in our syllabus we have four properties. One is the elasticity, second one is the surface tension, third one capillarity, and fourth one is the viscosity. In this session we will discuss about the elasticity and surface tension. In next session we will discuss about the capillarity and viscosity extensively in the next lesson, next video, right? So first you see the whatever the benches you are you have in our class. Observe that it is made up of metal and wood. If we use a thermocol instead of wood, what happens? Everyone knows what happens if we use the thermocol sheet instead of wood, right? We are unable to sit, we are unable to put our bags, we are unable to put our books, right? See this, you can understand what happens if the iron frame is made up of iron, the frame is made up of iron. If we use this frame with a different material which is not that much stiff, that much hard, then what happens? It leads to the different adverse effects, right? And you want to do something, you want to manufacture a machine, you want to prepare a model of anything, right? You need some material. So you want to know the material's property. What is the property of this material? Is that properties are needed for us, or another properties are there, right? You have to understand, you have to study the property before selecting the material. See here, the cable wires are there and electrical wires are there. If you use the normal thread instead of this wire, electrical wire, can you transmit this electricity from switch from here to there? When you are switching on the switch, then fan is rotating, right? In between this switch and fan there is electric wire is there available. The wire is made up of zinc or aluminum or copper. But if you use a normal thread, is it possible to transmit the energy from here to there? Impossible, right? So you need to understand the property of material before you are going to use it. Observe these windows. Here we have the metal frame that is made up of iron. We can use a wood also, and glass plates are fixed in the metal frame. So glass plates are fixed in a metal frame. You are seeing outside view. If the glass is not there, instead of glass we are using wooden board or any other type of paper is there, or steel plate we are using, then you are unable to see the outer view. So before selecting the material, which we need. What are the needs of our, then you have to select the body, sorry, you have to select the material. To select a material to perform any practical or to perform a project, to prepare a project or to construct a machinery, you need to understand the property of matter. This is very very important criteria to know the about the matter, right? If you don't know the property of a matter, whether it's a crystal or it's a strong, weak, soft, hard, like that, or transparent, opaque, conductor, non-conductor, we can divide these materials in different categories based on the properties. If you are seeing the same material, for example take wood, iron, if you are conducting you are studying about the electrical property, one is a conductor, another one is a non-conductor, right? If you take glass, it's a non-conductor, while you are seeing in seeing the electrical property. If you are studying or you are seeing in the view of optical property, glass becomes conductor, transparent, right? Wood is a opaque. So you need to understand, without having that nature, without having the inner property, we can't do with the material, right? So this is the most important to understand the properties of a body. This is the importance of studying this chapter. Here in this chapter we will discuss about extensively about the solids, and in surface tension we discuss about the properties of a liquid, right? Here in capillarity, the relation, some relation between the solid and liquid. So how changes, how much, how the liquid behaves well while it interact with the solid, like that, right? So here before entering into the chapter, we will discuss about a body. The matter is divided into solids, liquids, and gases. So here in solids, we have hard material, soft material, amorphous, crystalline, right? Like this, different categories are there. So we will study a body with constructive lattice, right? If you are applying some force on the body, its size or shape does not change, right? A body does not undergoes any change in its shape or size under the action of any amount of force. If you are applying large amount of force or small amount of force, there is no change in the size, shape, structure, right? That type of bodies are called as a rigid body. If you use any amount of force, it is not changing, no change, that is called as a perfect rigid body. But the perfect rigid bodies are ideal only, right? See, this book is a solid material. I am applying some force from upside, its shape changes. When you apply it from sides, its shape also changes, size also changes, right? This body is not an exact rigid body. A rigid body is a body, if you throw it, it goes totally, whole body moves from one place to another place, and there is no change in the, there may be change, but after it regains its shape and size. A body whose shape and size does not change when you apply an external force, then that body is called as a rigid body, and the body moves wholly from one place to another place. The displacement, the whole body goes from here to there. If you throw a stone, that stone moves from here to there. But if you throw a sand, right, the sand spreads from here to there, not from here to there. From here to there it spreads. Whole body is not moving, right? That type of bodies are not called as rigid bodies. Now observe me, I am applying some force on this wall. I am trying to move the wall. Will the wall moves? No, my force is not sufficient to move this wall. And observe here, the duster is on a table. I am applying some little force, then the duster is moving, right? I applied force in these two cases, but in one case the body is moving, another case it is not moving. There I tried, it moved. Here I am trying but not moving, right? This type of force is called as a deformation force. A force which changes or tries to change the shape or size or both without moving it as a whole in the is called as a deformation force. You apply some force on textbook, its size and shape changes. You see him apply some more force on the desk, some bending will be there on the wooden sheet. Apply some force with your foot on the floor, no change is there, but you are trying to move, trying to change. That type of force is called as a deformation force. In all these cases, take a spring and stretch it, right? Take a pipe and bend it. See all the figures, right? If you release this rubber band, then it regains its original shape when you remove the force. See here, a duster, sponge duster is this. This is a sponge duster. See here, I am applying some force from up and down sides. Its shape and size changes, right? Totally I am crushing it. It becomes very small and rectangular shape changes to different types, sizes. When I remove with my fingers, when I remove my force, it comes to its original shape, right? So due to the internally resisting opposing force, the body regains its shape and size. You friends, please, your one friend comes and he is applying some force, he is pushing, he is sitting on your shoulder. Then you unconsciously you opposes the force which is applied by your friend, right? You will try to push up, your friend tries to push down, right? This is the internal force, internally generated force. That is the external force. This internally generated force is called as a restoring force. It is a restoring force. Due to this, a body, when you remove external force on any body, some of the bodies, not any body, they regains its original shape and size. Then that property is called as elasticity. The material's property which has ability to regain its original shape and size that is called as a elasticity. The property of a body which it resists deformation force and regains its original shape or size when deformation force is removed. That property is called as a elasticity. When you apply some force on a spring, its size changes, decreases, release it, it regains its original shape. Right? If a body has this type of property, a body which regains its original shape and size when the external deformation force is removed or withdrawn from the body, that body is called as a elastic body. For example, quartz, rubber, steel, etc. comes under the elastic bodies. And some of the bodies cannot regain its original shape and size when deformation force is removed. Observe this chalk. I am applying some force, I am increasing force, then it changes, it cuts into two pieces. Right? Never it becomes one piece. This is a permanent deformation. When you bend an iron strip, it will be like that only. If you bend a iron strip, this is an iron strip, you bend it, if it is like this, and when you remove the force, then it comes to its original position. This is a temporary deformation. If you are applying force on this direction, then it comes like this. If you are applying some force on this one, they break into two pieces. That is a permanent deformation. Some of the material, some of the bodies does not regains its original shape and size when the deformation force is withdrawn from the body. That type of materials called as inelastic bodies. For example, chewing gum, lead solder, wax, wet clay, right? Or these inelastic bodies are also called as plastic bodies. The plastic body has some property. It is virtue of which the deformation force sets into retained even after applied force is withdrawn. Even after you withdrawn the applied force, due to the deformation force, the body size remains in that structure or that design, that shape and size. It does not regain, does not comes into original shape. That property is called as the plasticity. The body who does not comes into its original shape are called as inelastic bodies or plastic bodies. Right? So when you are applying some force on any body, you are applying some force on body, that is a load or deformation force. It's, for example, this is a rod, iron rod. You are applying some force on this, you are tapping with a hammer, then its size increases, right? See here, if you are applying some force, its size long stress and small, right? Something happens. So the force known as the internally some force automatically set up within the body, internal force set up in the body, that is restoring force. You are applying some load or you are applying deformation force, then restoring force acts develops inside the body. If the spring is here, this is loaded with some load, right? Then automatically it goes down, but this load is taken by the spring due to the internally increased restoring force of the spring. Internally increased restoring force of the spring. So as long as deformation force is small, the restoring force also comes into action within the body, equal and opposite to the deformation force. If you remove this deformation force, then it regains its original shape and size. So the restoring force developed inside the body per unit area is called as a stress. Stress is defined as the restoring force or recovering force per unit area set up inside the body. Alright, so stress equals to force by area, where F is stress, S is the stress, F is the force, and A is the area. The units for the stress are Newton per meter square. Newton for force, area, meter square. So Newton per meter square, or it is called as a Pascal. And CGS units are dyne per centimeter square. Dyne per centimeter square. These are the units for the dimension stress. And dimensional formula for the stress equals to force by area. So force dimensional formula is ml t inverse square by L, area is a L square. So L square 1 minus 2 1. So m L inverse t inverse square is the dimensional formula for the stress. Right? This stress is a restoring force develops inside the body per unit area when you are applying some external deformation force on the body. See, when you apply some force on any body, for example, it is a straight, this is a iron rod. If you are tapping with the hammer, then its length increases, right? Some change in the length. If the body is a two-dimensional metal sheet, you are tapping it, then its length increases or width increases, or both the length and width increases. If the body is a three-dimensional body, length and width increases, height decreases, length and width increases. So this is a change in one dimension, this is a change in two dimension, and here a change in three dimension, two dimension, one dimension. Some change is there. The change occurred produced in one dimension of the body per unit dimension is called as a strain. Strain is nothing but the change in a dimension per unit dimension. Here change in the dimension but unit dimension means this is a ratio between the two same physical quantities, so there is no unit and no dimensional formula for strain. This is most important for the examination point of a small question will be rises. Write the units for stress and strain. You can write the units for stress are Pascal in SI system, and for strain you have to write no units or no dimensional formula. If you think some students thought that there is no dimension, so no need to write the units. There is no units and no dimensional formula, so they think no need to write the units and dimension formula. If in that case the examiner also thinks no need to give a mark, right? So you have to mention there is no unit, no dimensional formula for strain. And if you are applying some force, here we have the different types of stress, different types of strains. One is types of stress: longitudinal stress, volume stress, shearing stress. Longitudinal means a perpendicular to the cross sectional area. If some load is there, then it changes its length. right? This is a rod. If you are applying some load, its length increases. This is a longitudinal change, right? In volumetric change, if it is a two-dimensional, you are applying some deformation force, its area changes. And shearing stress, you are applying some force on the tangential, then it moves. If you take book and push at the but upper area of the book, then it goes down. Like everyone knows the cards, if you put all the cards and press at one place, then it moves, right? And strain also three types. Strain also three types, that is the longitudinal strain or linear strain. Next one is the volume strain, and another one is the shearing strain. Here in strain, longitudinal strain means the change in length. For example, this is a length, this is a iron rod. This is iron rod, you are applying some force, its length increases. So delta L is a length increase, the original length is L, then L delta L change by original length. This is a longitudinal strain. And if you are applying some force on a volume, then volume strain is the dV by V, change in a volume by original volume. And next one is a lateral strain, shearing strain. It is defined as the angle through which it is straight line, right? This is the angle through which, this is the angle the object is moving, right? Defined as the ratio of relative displacement between the two layers under the action of tangential force acting in this direction, then you will get a some. For example, the object is like this, right? You are applying tangentially some force, tangentially you are applying some force, so the object moves like this, so it makes certain angle here. This is called as a shearing stress. So we have three types of stress, three types of strains, right? So you take a normal iron wire, in normal language we call it binding wire, bend it twice, thrice and continue the bending, right? At certain time it breaks into pieces, right? Stretch the rubber band to certain extent, remove your force, then it comes its original shape, it regains original shape and size, otherwise it breaks into pieces. There is permanent deformation will be there if you continuously apply some force on the body. So up to certain maximum value it regains its original shape. Beyond that maximum value it gets permanent deformation. So the maximum value of stress within which the body completely regains, the maximum value of stress within which a body completely regains its original shape and size when the deformation force is removed or deformation force is withdrawn, the maximum value of stress is called as a elastic limit. This elastic limit is most important while understanding the stress strains. Beyond this maximum limit, beyond this elastic limit, body gets permanent deformation. For perfect rigid bodies, elastic limit is maximum, and for perfect plastic body, elastic limit is minimum. Within the elastic limit, within this elastic limit, the applied force on a body is directly proportional to the strain produced in a body. This is called as a Hoax law. This basic law of elasticity is given by Robert Hooke of England. According to Hooke's, within the elastic limit, the stress is directly proportional to strain. If stress increases, strain increases. Stress stress is directly proportional to strain. Right? Stress increases, strain increases. So stress by strain equals to some constant E. The E is called as the coefficient of elasticity or modulus of the elasticity of the material of the body. Hooke's law states that within the elastic limit, the stress is proportional to strain. It is given by the Hooke's. Right? Hooke's law holds for good for three types of strains, but different type of strains. The modulus has a different value, is defined as this E value is defined three types. One is a Young's modulus, another one is a bulk modulus, third one is a rigidity modulus. So modulus of elasticity is equals to stress by strain. If longitudinal stress, longitudinal force by area, shearing stress, shearing force by area, bulk stress, normal force by area, longitudinal strain, length by length, shearing strain, length by length. It's a change in dimension. Volume is a volume by volume. Young's modulus is the ratio of longitudinal stress by longitudinal strain. Here, the Young's modulus is defined as the ratio between longitudinal stress and longitudinal strain. For example, here the body is loaded, a rod is loaded with some load metal, then its value increases, its length increases from here to there. This is a change in length. So longitudinal stress is force by area. Longitudinal strain is change in length by length, capital original length. So Young's modulus is represented by Y. It is given as longitudinal stress by longitudinal strain. What is longitudinal stress? Longitudinal stress is force by area, and longitudinal strain is change in length by original length. So F by A into L by delta L. This is the Young's modulus, where F is a force, that is mg. Right? This is the Young's modulus of a wire. Next here, some forces acts in between. According to the syllabus, we have only in our syllabus we have only the longitudinal stress types of strains, and name the types of strains, types of strain, and modulus, coefficient of elasticity, and Young's modulus only. We are not having these other types of moduluses in our syllabus, right? As per our diploma SBT Telangana syllabus, it is only Young's modulus is there. Next, enter into the understanding of some forces which are bonded in between the bonds between the solids and liquids. So cohesive forces. Cohesive forces are the forces in between the same particles. Particles should be same. the particle of water particle and water particle, right? Oil, oil particle, alum, copper, milk, milk particle, right? The force between the two same particles is called as a cohesive forces. And different particles, if the force between different particles, that is called as the adhesive force. You can see on a fevistick fevicol adhesive gum, right? So adhesive force is a force between the paper and different type of particles. For example, observe the forces between the water molecule and water molecule, milk molecule and milk molecule, that is the cohesive force. And observe, pour some water in a glass which is made up of glass or steel glass. Use a steel glass and pour some milk and empty the bottle, empty the glass. Then you can see the some of the milk is stick to the boundary sides of a glass. That is, there is a attractive force between the milk particle and the glass particle, right? That type of different forces, particle forces are called as a cohesive and adhesive forces. If the milk molecule, that is a water molecule, copper molecule, that is the cohesive force, the same. The force between the same particles is called as a cohesive force. The force between the different molecules or different particles called as a adhesive forces. Right? Now we will discuss about a second property according to our syllabus. First property is the elasticity and second property is the surface tension. Right? So here you will observe the soap bubbles and mosquitoes lays eggs on a water, and a needle placed on a water does not sink into the water, and a brush put in a paint. You apply some oil to your hair, they comes closer. Raindrops are spherical. Mosquitoes breeds on water. Small insects walks on the water. These are all the natural phenomena we are observing in our areas. So why these are happens on the surface of a water, right? Due to the some layer is there, is the layer is forming on a surface of a water, that's why the insects are walking on the water, and mosquitoes lays eggs on the water, and raindrop is a spherical when it is coming down. You apply some coconut oil or any other type of oil to your hair, they becomes closer. Put a brush in a paint, the brush hairs comes together. These are all due to the surface tension. These are the all can be considered as the examples of illustrations or examples of the surface tension. Here on a surface of a layer, what liquid, some membrane type layer develops on the surface, and inner surface molecules pulls the upper molecules. Due to the pulling force of the downward molecules, upper area of a liquid behaves like a stretched membrane. The property is called as a surface tension. The stretched membrane behavior of a liquid is called as a surface tension. You observe hot water, hot milk, hot coffee, put it for 5 minutes or some time, then you observe the coffee or milk, there is a small layer like cover, right? You can pick up that cover also, that layer also. That type of membrane develops on a surface of a body is called as a surface tension. The force per unit length acting on either side of an imaginary line. For example, here this is the surface, right? I am drawing a imaginary line AB, and the forces are acting two sides, both the sides of this imaginary line, right? This is called as a how much force is acting either side of this imaginary line drawn on the surface of a liquid at rest position is called as a surface tension. Surface tension is denoted by the capital T. So surface tension equals to force by length, the force acting per unit length. So force by L, the units for dimension, units, SI units for this surface tension is newtons per meter, CGS units are dynes per centimeter, dynes per centimeter, and dimensional formula is m L0 T inverse square is the dimensional formula for the surface tension. The surface tension can be explained based on molecular theory. Surface tension can be explained based on molecular theory. Observe the liquid. This is a sphere of influence. Observe the bar, this one A. Here this red point is a particle molecule. Side molecules are attracted by this molecule. Each and every particle is attracted by the neighboring particles. So this neighboring attractive force between this neighboring particle with the same radius, draw a circle. It is called as a sphere of a influence. Observe this A sphere. It is inside the liquid, so all the neighboring particles are acting simultaneously on this sphere A. So net resultant force becomes 0, so it does not move from anywhere to sides. And coming to the B, which is near to the surface, but 60% of the sphere of influence is under the water and remaining 40% of the sphere is upper the water, right? Then what happens? The net resultant force is acting downward because 60% is downward, for only 40% is upward direction. So here the downward particles are pulling the surface particles downward direction, right? Now observe this sphere of influence C. Most of the particles sphere is, half of the sphere is under the water and half of the sphere is above the water. So at this point most of the particles pulls downward, right? So this area is behave like a stretched membrane. So based on this sphere of influence, based on the molecular theory, we can explain the surface tension. This is the most important concept to understand the surface tension, how the molecules attracts neighboring molecules and how the upper layer of the molecule liquid behaves like a stretched membrane. Due to this property only, the soap bubbles are spherical, water droplets are spherical. Each and every liquid drop tries to reduce its area, cross-sectional area and its volume. That's why the it tries to reduce its volume. That's why it becomes a spherical, right? The examples for the surface tension are the soap bubbles. If you produce soap bubbles with some ring and soap water, then first the bubble shape is different, dumbbell shape or oval shape, different shape, but after it comes out from the ring, it becomes a spherical. And water droplets are spherical. Mosquitoes lays on eggs on the water, the insects walk on the water. All are these all are due to the surface tension property, right? The surface tension can be explained by the molecular theory. With this we conclude here. In next class we will discuss about the angle of contact, capillarity and viscosity. In this chapter we covered the property of elasticity and property of the surface tension. Thank you.